All right, so number 25 talks about marriage. And so, first of all, we're going to do a 1 mean t-test. My hypothesis is mu. Now, that's the Greek letter mu, mu. Remember, we use Greek for population. And they said it's 23.3. And so 23.3. And I recommend that you put units down so we have an idea of what the units are. And they want to see if they have increased. So HA would be that mu is greater than 23.3 years. Okay, so let's do our conditions. And the first one is random. Hopefully it's stated there. They say, if you look at D, they said they took a sample. And so it's not stated, so we have to, I don't see it anywhere. So we have to say that assume that the males the married males, no, that the men are chosen randomly. It's just men. I had to go look it up. Okay, so let's do 10% condition. And they say that we have 40 men, hot diggity dog, 40 is a good number, is less than 10% of all men. All right, so I need to go to the next slide to continue this. All right, and so the last one is large enough. The book calls it nearly normal. All right, and so since 40 is a large number, it's greater than 30, the central limit theorem tells us that we have a normal distribution. Due to the central limit theorem, due to the central limit theorem, our distribution is normal. Okay, so remember, we want our distribution to be normal, but we're going to use a t-distribution to solve the problem. So we're going to say conditions for t-distribution exist. Okay, so I met my conditions. Okay, C is kind of a weird thing. So basically I'm going to do a z-score math, but it's going to be t. And every t is different depending on its degrees of freedom. So I'm going to write t sub 39. And it's going to be what I am curious about, my mean minus the accepted mean, which is 23.3, divided by my standard deviation, divided by the square root of 40. Okay, so now let's go to D, and it says they tell us in D that they took a sample of 40 people, and the average was 24.2 with a standard deviation of 5.3. So we have T sub 39 is equal to 24.2 minus 23.3 divided by 5.3 divided by the square root of 40. Okay, so I'm going to go find my answer, and I'm going to go find my p-value. Okay, so in case you don't know where I went to stats, testing, and then I went to t-test number 2. All right, so my t is going to be 0.54. All right, so the probability that x bar is greater than 23.3 is equal to the probability that z is greater than 0.54 is equal to my p-value is 3021. So hopefully you realize that my p-value is big. I don't see any mention here of alpha. So we will fail to reject my HO since my p-value 0.3021 is big. All right, and so we're going to fail to reject that there's evidence that there is evidence that the age of first marriage for males has not increased. Okay, now let me go read this. I don't know if this is exactly what they want. Okay, I realized I made a mistake. I'm sorry. I had n equals 10 in my calculator. I was wondering why I got a different answer. So the z is going to be 1.07. Okay. So here I will change this, to be negative 1.07, and then I will have 0.14, is it 42? 47. Sorry about that. Put it in here. Okay, still big. Okay, I answered E, so let's go do D. D is the one about the p-value. And so what they want to know, remember the p-value is if HO is true. So if HO is true, if the average age of first marriages for males is 23.3 years, there is a 14.47% chance that when sampling a mean of 24.2 years can happen. Remember, it's a probability that if HO is true, what's the probability that HA can happen, okay? And the answer is 14.47. That's what the p-value is. All right, so remember, we'll have a quiz on confidence intervals and hypothesis testing.